Hi, I'm Lior Ainey from MultiPhy. I'm a verification engineer, team leader responsible for the 100 gig project of our company. So my latest project is a 5-layer chip. This chip handles 100 gigabit per second of information over one single wavelength. This project is using a 60 nanometer process, and it's actually it's a mixed signal chip. The chip is using very high speed analog interfaces together with state-of-the-art DSP. So I think the most challenging aspect of the verification was the fact that we were facing different kind of blocks. We had blocks like doing bit manipulation, framing. We had different blocks for doing verification of our analog devices, analog interfaces, high-speed ones. And also, I think the most difficult task was to verify our DSP blocks. This is because we had to face new challenges and new methodologies during this process. So when I'm looking for a solution, I'm looking for several things. The first is a quick development flow. I want the flow to be very fast so we can go to market very quickly. I'm looking for a good debug flow, so it would be easier to find bugs and fix them. We are also looking for a flexibility flow, so you can use this flow for other projects and for the same project, mainly developing for, let's say block level, and then reuse it for different kind of clusters and full chip. We are also looking for a flow that is good on performance terms. So Specman is a very mature language. It exists for many years, and new features are added to this language each year. The aspect-oriented concept is great. It helps us create new tests and update our verification environment very easily. So the reusability is great. Another thing is the debug. Debug flow is very intuitive in this language, and it's very easy to find bugs and fix them. So there are several schemes for doing verification using MATLAB. Some of them are using the MATLAB as the engine of this process. So there is one flow that uses a connection between the MATLAB and the HDL directly, so we don't need a verification environment. Another flow is using separate flows for this process. One flow is running a simulation, the verification environment and the HDL, dumping the results into a file, and in a different flow they're running the MATLAB as a reference model and also dumping the expected results to a file. After that, these files are compared to see if they match. So these schemes are very good, but there have some disadvantages in them. The first one is the debug. The debug is very bad in these terms because it's easy to understand exactly when you have a mismatch where the problem is. And when you're using these flows, I think it's harder to understand what the problem is coming from. Another disadvantage is that you need an extra toolbox for this process. In our scheme, we are connecting the MATLAB directly to the verification environment. So the verification environment in one hand has the MATLAB as a reference model, and on the other hand it has the design. So the flow is using a Cadence MATLAB adapter, which is an API that uses MATLAB C and C++ connection, and this API helps us connect directly to the MATLAB itself. We developed a unit in our verification environment which we call MATLAB adapter. This unit actually is responsible for all the communication between the verification environment and the MATLAB. We developed two APIs, two interfaces. One of them is responsible for all the flow of creating the MATLAB model, initializing it and executing it. And a different API is handling the lower details, exactly how to connect this verification environment to the MATLAB itself. It's using different commands that the language allows us to use, And this is how we achieve a very unified verification environment. So all the flows, all the verification environments that are handling MATLAB are look the same. And it's very helpful for a quick debug and quick cycle of development. So using the approach we developed, we found it very efficient in terms of time to market. The verification environment process was very fast. We developed many blocks in a very quick time, and also the debug was very good because we had a visibility both of the verification environment and the design, and also the reference model itself, so we can find bugs very easily and fix them. Also the reuse was very good, so we could take one environment that we developed in block level and took it for different aspects like cluster level or full chip, and we also plan to use this verification environment for other projects. I think that using Cadence tools together with MATLAB, we had a very good experience, and we were looking forward to do it again in our next projects.